All right, let's jump right into this explainer because we are looking at a massive paradigm shift today. Think about it. What actually happens when we stop treating AI like some glorified chatbot and start treating it like a dedicated, full-time digital sysadmin? For a long time, our default interaction with artificial intelligence has been completely transactional. You type a prompt into a text box, you get your answer, and boom, the transaction is over. But today, we're looking at an entirely different beast. We're talking about an architecture where an AI agent isn't just passively answering questions, but is actively orchestrating, building, and maintaining complex web infrastructure around the clock. To really wrap our heads around this, we need to talk about Jack. Jack is an OpenClaw agent, but here's the kicker. He doesn't live on a fragile local laptop. He operates 24/7 on a dedicated 48 GB RAM Contabo server out in Munich. The contrast here is just stark. Think about your laptop. It's deeply personal, sure, but it's fundamentally fragile as a continuous work environment. It goes to sleep, it drops Wi-Fi, you close the lid. By putting Jack on a dedicated virtual private server, he instantly transforms from a momentary assistant into a persistent operator. He just sits there, keeping the build process alive, inspecting sites, and reporting back. It's the difference between asking someone a one-off question and assigning them a permanent, continuous mission. And Jack's current mission? It is absolutely monumental. He's actively operating and building the infrastructure for CalculationTime.com. The goal is to make this the globally trusted platform for everything from basic time math to complex space and orbital mechanics. We aren't just talking about spinning up a simple tip calculator here. This is a comprehensive, massive directory designed to be the absolute authority for complex calculations. The ambition is huge, to build the exact kind of site that search engines trust, human users rely on daily, and honestly, even other AI assistants cite when they need to pull a highly specific calculation. We're talking about serious heavy-hitting utility. Take a payroll time card calculator, for instance. This kind of tool demands absolute precision and a rock-solid backend because it literally handles people's money and their logged work hours. It has to be completely trusted by both users and search algorithms alike. And this perfectly illustrates why Jack's role as a sysadmin and developer is so absolutely critical. A payroll tool cannot be buggy, and it definitely cannot fail under a heavy server load. For a platform to scale up and offer tools like this, alongside mortgage calculators, percentage tools, business utilities, every single page needs to be genuinely useful and mathematically flawless. Now, here is the truly wild part. Jack completely bypassed the whole bloated monolith trap. Instead, he architected a highly modular dual-engine infrastructure right there on the VPS. Jack isn't just throwing together some front-end HTML, he is acting as a full-stack infrastructure architect. He designed a system that kicks off with a hardened Nginx global gateway to strictly manage API keys and rate limits. Right behind that, he set up this robust caching and persistence layer using Redis and a hardened PostgreSQL database. And perhaps the most impressive flex, he split the actual compute workloads into two entirely separate engines, completely avoiding the mistake of jamming everything into one giant sluggish application. And this setup brilliantly illustrates his logic. He completely separated standard everyday web requests from what he calls Engine 2. Engine 2 is a dedicated Python microservice built strictly for heavy astronomical math, stuff like tracking eclipses or calculating real-time star coordinates. So Engine 1 handles the rapid-fire stuff, utilizing Node.js and FastAPI for those high-throughput everyday time and date calculations. But Engine 2, that's built with Python and FastAPI. Why? Because Python has incredible heavy-duty scientific libraries like Skyfield and Astropy. By decoupling this, Jack ensures that a massive influx of users trying to calculate their Friday payroll won't suddenly crash the server while it's simultaneously grinding through the exact orbital mechanics of the moon. Pretty smart, right? So let's pivot to a very specific challenge for Engine 1, which handles the time and date calculations. This really shows how Jack's intelligence goes way beyond just writing standard boilerplate code. When you're building a global time calculation platform, dealing with time zones is, notoriously, one of the single most frustrating problems in computer science. Daylight savings time changes, governments randomly shift their borders, local time roles are constantly in flux. The reality is, if you build the database architecture wrong from day one, your entire platform will eventually start spitting out incorrect results. Now, what's fascinating here is Jack's architectural correction. He actually stopped the system from storing those fragile, shifting time zone offsets in Postgres. Instead, he strictly mandated the use of raw IANA time zone IDs as the absolute source of truth. Usually, a junior dev might just save a time as UTC-5 in a database and call it a day. But Jack flagged that as a critical flaw. Static SQL offsets break the very second daylight saving time kicks in or ends. By forcing the system to rely on raw IANA time zone database calculations, using identifiers like America/New York rather than a hard-coded -5, Jack ensured the platform's time logic remains perfectly accurate forever, completely immune to global time policy changes. That is exactly the kind of proactive, senior-level sysadmin intelligence we're talking about here. But Jack isn't just hyper-focused on time logic. He's seriously multitasking across this server. He's actively managing a self-hosted Supabase instance that powers both calculation time and a totally separate AI inquiry platform called Aperture. Aperture is this premium, secular contemplative platform built around privacy and an AI-driven inquiry engine powered by Gemini Pro. So this means Jack is running a true multi-tenant environment. He is managing a shared database backend serving two completely different software projects, and he's responsible for making sure they both run flawlessly without ever interfering with one another. So the crucial question is, how does Jack safely orchestrate this complex multi-app environment? Well, he takes three very distinct steps, specifically locking down memory caps to ensure neither app starves his own core OpenClaw daemon. First up, he generates high-entropy service role keys locally to lock down the connections. Second, he strictly isolates the database tables, which guarantees that Aperture's encrypted journal histories never ever mix with calculation times user metrics. And third, and this might be the most important, he enforces strict server RAM allocation limits. If the Node.js or Python engines suddenly spike in memory, Jack has mathematically guaranteed they will never consume all 48 gigabytes and crash the OpenClaw agent itself. He literally built the guardrails to keep himself online. Furthermore, Jack acts as this tireless, almost ruthless QA auditor. He manages messy Git branches and immediately flags any under construction template as needs build to maintain the project's integrity. If you look at the source logs, you see Jack relentlessly inspecting deployed pages to ensure they aren't just empty shells. To Jack, a calculator page doesn't just pass because a URL returns a 200 status code. If it has a placeholder, or if it's some bare-bones MVP still under construction, Jack applies a strict audit rule. It needs a build. He goes in, fetches the Git repository, identifies stale work trees, creates rollback markers, builds the static exports, and even runs local browser checks to ensure there's no horizontal overflow on mobile screens, all before a single line is pushed to production. But we really have to ground ourselves in the reality of this workflow. Jack is not some autonomous magic wand. He is the operational muscle. He executes the boundaries, the business strategy, and the aesthetic judgment that his human creator provides. And this is an incredibly important distinction to make. The human is still driving the ship, directing the project, setting the strict quality expectations, and providing that final green light. The human is the one who spots an awkward layout balance or confusing marketing copy that an AI would totally miss. Meanwhile, Jack does the heavy lifting, the complex Git merges, the tedious dependency updates, the static site generation. It is a true partnership. In fact, you could argue the workflow itself is the actual product being refined here. As we wrap up this explainer on the All OpenClaw experiment, I really want to leave you with this thought. Is it time for you to finally graduate from just prompting an AI to actually operating alongside one? We've just seen how a dedicated agent sitting on a server in Munich can architect dual-engine routing, strictly manage complex database states, and ruthlessly enforce quality control across multiple live applications. The shift from chatbot thinking to operator thinking isn't a future concept. It is happening right now. It is all about moving from random AI novelty to controlled, structured, infrastructure-level momentum. So take a hard look at your own workflows and ask yourself, what could you build if you had a Jack on your server?